Hello. In this lesson is going to be an overview and a review of what we did the prior day. Prior day we had quite a bit of information, so today is just an extra day to get a little bit of extra practice and kind of synthesize and summarize everything that we covered in the prior section. To start, I'd like to do the following warm-up questions. The second skill is definitely involved with what we're going to be doing today and what we did in the prior section, and we can't forget it. It was the first half of our unit. How do we multiply and divide, factor these quadratic expressions? So try these 4 questions. The first two is on how you multiply. You can either do double distribution or use the box technique, the table. And then the second one is, can you do the opposite? Can you factor it? If I give it to you all expanded, can you put it back together into factored form? So pause the video now for maybe a minute or two. Try these questions as review. See what you remember. Unpause it once you want to see the answers. Okay, here we go. Here's how you do it. The first one's you're multiplying. It's double distribution. You distribute the x first. X times x is x squared. X times 3 is 3x. Then you distribute the 5. 5 times x is 5x. 5 times 3 makes 15. If you add up all of your like terms, you have an x squared. 3x and 5x makes 8x and 15. You'll notice, why is this 15? Because that's the multiplication of 3 times 5. Why is that 8? Because that's the addition of 3 plus 5. That's how we're going to undo the opposite for the parts down below. Put it back into factored form. Over here, I'll use the box technique just to show it if you haven't seen it in a while. Table. So maybe I've got x plus 7, x minus 2, x times x is x squared, x times minus 2 is minus 2x, positive 7 times x is 7x, 7 times negative 2 is negative 14. You add up all your like pieces. I have x squared, 7x minus 2x is 5x, positive minus 14. There's your final answer. You'd get the same thing if you did double distribution. Notice, that is the multiplication of 7 and negative 2. That is the addition of 7 and negative 2. That's how I'm going to do the ones down below. In order to factor, I need to find the numbers that multiply to be 8 and add up to be 6, and that's 2 and 4. So it has to be x plus 2 and x plus 4. You should be pretty quick at these by now, hopefully. Over here, this is a 1 out in front of the middle x term. So I need two numbers that multiply to make a negative 12 and add up to be 1. They need to be opposite in sign because they multiply to be a negative, and the bigger number needs to be positive, so it's got to be a 4 and a minus 3. 6 and negative 2 add up to be 4, 12 and negative 1 add up to be 11. The only combination that works is positive 4 and negative 3. There you go. That's an overview of the first half of the unit. Now what we're going to do is review how we used factoring to actually graph quadratic functions. So here we go. If I want to graph the following quadratic function, I want to first find the x-intercepts, also known as the zeros or the roots. They're the x values that make y be 0. So I need to factor the following equation. That's why we practice factoring in the warm-up. I need two numbers that are going to multiply to make 12 and add up to be 8. Those two numbers are going to be 2 and 6. Now it's factored. The zeros are going to be negative 2 and negative 6. Those are the zeros, the roots, the x-intercepts, whatever you would like to call them. They all imply the same thing, essentially. Once I have the x-intercepts, the vertex has to be halfway in between. The vertex's x-coordinate is halfway between. You can just see it's going to be negative 4, but if you average those two values, add them together, divide by 2, you'll get negative 4. That is actually also known as your axis of symmetry. So your axis of symmetry is x equals negative 4. If you know the vertex's x-coordinate, how do you get the y-coordinate? You put negative 4 in for your x value. So you get negative 4 squared plus 8 times negative 4 plus 12. That'll be 16 minus 32 plus 12. That's going to be what? Negative 16 plus 12. It looks to me like it's going to be negative 4 again. So negative 4, negative 4. It doesn't always work out to be like that, but it is in this case. So negative 4, negative 4. I want to check and make sure that we did that right real quick. So negative 4, just double checking. Yep, we did that right. Now the last part is the y-intercept. The y-intercept is your y value when x is 0, which will always be that last term, that constant term. If I put 0 in for x, I get 0 plus 0 plus 12. So that's just going to be 12. I have the right, so 12 somewhere like right there. I have the right side of my graph. There's a mirror image point right over there. Left side of my graph, and now I've graphed the quadratic. It's a good overview of what we did in the prior section. So there you go. I'm going to ask you to try one. Make sure you've understood what we've been working on. This is a big, big topic. That's why we're taking 2 days to kind of tackle it. I'd like you to try the following. Can you factor and graph it by factoring the following equation? So factor it first, find the x-intercepts, split them in half to find the vertex, use the y-intercept and its reflection, plot all 5 points, and sketch the graph. So pause the video now to try this one for yourself. You can maybe try it at the top of where you would do the homework assignment or just on a scratch piece of paper, and then come back once you've given it a try. So pause the video now, please. Okay, let's go through it. First thing you want to do is factor it. Two numbers that multiply to be 3 and add up to be 4 are 1 and 3. The x-intercepts then are the values for x that make y be 0. In this case, it'd be -1 and -3. You should just be able to know that the point halfway between -1 and -3 is -2. If I put -2 in my equation for x, I get a y coordinate of -1. So there's my two x-intercepts right there. There's my vertex. My y-intercept is 3, the number at the end. Sketch in the right side, reflect the left side, and you're all done. Looking at it all at once, it looks like that. We'll try one last one special case one, where you have to do factoring by doing greatest common factor factoring, because there's only 2 terms. So first step, factor the equation. I can't do the multiply add because there is no term at the end. So what I'm going to do instead is do greatest common factor factoring. I want to know when is y 0. My equation is -1x squared minus 3x. What do -1 and -3 both have in common? They both have a -1. What do x squared and x both have in common? They both have an x. So that's what I'm going to divide out. What is left behind? Well, the only thing left in the first one is there's a single x left behind. This was a -3, but I divided out a -1, so there's a +3 left behind. This only had one x, and I divided it out, so now it's completely factored. How do I know? Because if I multiply back through, I get the original statement. If I distribute through, and x and 3 have nothing in common, so it's completely simplified. Now that it's factored, I can find the x-intercepts. What can I multiply -1 by to make 0? Well, x equals 0 would work. -1 times 0. Some people think 1, but that's not true. -1 times 1 does not make 0. Over here, x has to be -3. So 0 and -3 are my x-intercepts. I hope by now you can kind of realize you can use the formula, but halfway between 0 and -3 is -1.5. So I'm just going to note that. That is also where my axis of symmetry is going to be, halfway between the two x-intercepts. How do I find where the vertex is actually located? I put -1.5 in for x in my equation. So my vertex is y coordinate would be -1.5 squared minus 3 times -1.5. You got to be really careful here. Lots of negatives. I'm actually going to show you a nice little feature on the graphing calculator if you have one. So if you have a graphing calculator, you can do what's called store a variable. So I'm going to save -1.5 as my x. And what you do is you type in -1.5, you hit STO, it stands for store, and then you hit this x variable button right here, and then you hit enter. And now, whenever you grab x, 2 times x is -3, because it thinks that x is -1.5, because that's what you told it. Now what we're going to do is we're going to type our equation in, -x squared subtract 3x, and it will just run the calculation for us. 2.25 is what this should end up being. So my vertex is at -1.5, positive 2.25, right there. There's a +0 at the end here, so my y-intercept is actually the origin. It's also an x-intercept in this case. I mentioned in the last lesson that when you have greatest common factoring problems, you're only going to get 3 points as opposed to the 5 we've got before. You sketch in the one side, the other side's going to be just a mirror image of it, and then you're done. And that's it. It's kind of a shorter lesson because it was just an overview. Hopefully maybe this filled in any lingering questions you might have had. So thank you very much. Have a good day.